Hello. I've just spent the night going through Schrodinger's paper and listening to his advice. And before I continue on, want to talk about numbering videos. The way I'm numbering videos, and this is just so we're organized here. I usually have videos going number 1 or UFT, number 1, 2, 3, etc. We're at 6 all the way down. I got 13 here, I think. Now at number 6, we had a question, so I'm branching off. This is now number 6A. This one happens to be number 6B, 6C if it's necessary, and so forth. So if there's a question and so forth, I need explanation on this one. We'll go over to 6B1, 6B2, dot, 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 and create a pattern that way. I'll have to go back to 7. I'll create a 7A, 7B, etc., or maybe an 8B if it's a sidebar on this, going through the sidebar. Okay, now with Schrodinger's paper. This is the one I'm working on. Second series, December 1926, volume 28, number 6 of the Physical Review, titled Undulatory Theory of the Mechanics of Atoms and Molecules by Edwin Schrodinger. Edwin Schrodinger uses within this paper this particular formula, and he uses separation of variables. And he talks about different characteristic functions, and also talks about, he's using eigenvalues from the characteristics. And talks about psi, which is a spatially defined or spatially dependent function rather than a time and spatially dependent. Yes. And let's see, on page 1058 rather, 1058, 57, that matters, 1058, he talks about the exact and utterly tiresome proof of the foregoing statements. That's with separation of variables. He talks about the solution may be performed in three-dimensional polar coordinates, and so forth, by assuming psi to be a product of the function of these different angles. So, to explain that a little better, and what I've done, and the mistake I've made, and yes, it is a mistake, what has happened as we go along, Schrodinger talks about the Bohr model, and he talks about the Bohr model, I use red, being at the center, we have positively charged item known as proton, and around this we have some electron, and this electron is in a Keplerian orbit. This is Niels Bohr. Schrodinger rejects this model, and he talks of a different model in which we basically have a positive part in the center, and around this we have a sphere, around this a surface, etc. And this surface is not a particle, etc., that is in orbit. He says it can't be in a plane orbit, it must be spherical. So this is a sphere. On the surface there's something called psi, and it is a vibrating surface. Rather than a surface that expands and so forth. This is a vibrating surface. The overtones of the vibrations are really determined by the eigenvalues, the infinite number of eigenvalues, to the solution on this particular side, or the solution to this set. Now my error, this one, my model was not like this one. The model that I had set up looked like this. Because I was using Cartesian coordinates and so forth, and basically what Schrodinger is telling me is an atom doesn't look like this at all. An atom is really a sphere Okay? And with this particular sphere, we have a surface on it that is working. Secondly, Schrodinger does go into discussions on whether it's imaginary or real. We can see here, this is an imaginary number. These are all real numbers. That's an imaginary number. And it's equal to something that's real on this side. We can't have that. But we do. And it works. And therefore, certain things happen with, and Schrodinger was talking about an infinite region out here with solution to the Hamiltonian and Laplacian operator out here. However, he says that if this happens to be an imaginary solution, everything reverses back in on itself. It's a joy for me to see how he is talking. We describe this whole thing as entirely backwards. So we invert the whole thing back in to be the interior of this sort of sphere here. He does not talk about boundary conditions. He gets the same solution for the time separated part. Now, with the time separated part, another thing that Schrodinger does is that his nomenclature is he uses psi for time only. He also uses psi for space only, and he uses psi for both time and space, all kind of mixed up. So I'll be using different functions for this. So to separate this out, V, according to Schrodinger, equals V is really equal to minus E squared, where that's the fundamental charge, over R, and he solves that to be the Bohr radius by using eigenvalues on that part. So to separate out, we have psi is going to be of two functions. It's going to be of time, and it's going to be of spatial coordinates. I'll set those spatial coordinates by the word, just the little letter S. Those just mean spatial coordinates. I'm going to say that's equal to the product of two functions. The product of two functions. Capital T, which is a function of time only, and a function, as capital S, which is a function of the spatial coordinates only and not time. Right. Since we will be dividing out, there are prerequisites in using this, which is that psi of t can never equal 0. The spatial coordinates of this s function can never equal 0. T can equal 0. S, the little s, the variables can equal 0, but the function cannot. Yes, okay, so to put this into separation of variables, we have I, H bar. I'm going to just simply write, and just simply write T prime, meaning that's d by dt, or of its variable within itself, of the dependent variable, times S would be equal to minus H bar squared over twice M del squared bracket TS plus V is a function of R times TS. Now, the reason we made that non-zero is we divide by psi to separate the variables, divided by T. S, we can all see what's happening. T is going to go out, divided by TS. Since del squared does not operate on the function t, but only on s, we would have t del squared s. So we would end up with this situation. S's cancel, t's cancel, t and s cancel, leaving a function of r only. As a result, goes away. T's cancel, s's cancel. Now, this side is a function of time only. This is a function of space only. If I keep time constant and I vary the spatial coordinates, which I can, this will not be affected. Therefore, this entire side must equal a constant. If I keep spatial coordinates constant and allow time to pass, which does happen, this will not change. Therefore, no matter how time is, this side of the equation, not the function, but the side of the equation must be a constant, giving me I h bar t prime over t equals, I will make this constant some alpha, but to ensure that that the universe doesn't blow up, it's minus alpha squared. This minus alpha squared, by the way, this minus alpha squared, by the way, is also equal to E, so that Schrodinger uses the same denotation. He denotes E in the same way as minus alpha squared that I did. I've just taken it down to minus alpha squared. He uses the same thing with E. And he also bases, when he starts out throughout his paper, he is using that E equals h nu, which I have found the solution and driven that out of it. The other side, we have this entire side here, is also equal to a function. I'm going to make that function beta squared. And this satisfies certain conditions on imaginary and real parts to the solution. So we'll use that one equal to beta squared. This one's equal to alpha squared. And it is now separated, whether this is linear, nonlinear, regardless of this, so long as this function is dependent on space only.